Myself, Madhuri Modak, Assistant Professor in Mathematics, Department of Computer Science, Abhiday Namdar, Senior College. Now, in groups and coding theory, we start with the last unit, that is coding theory. Now, next definition is of group code. An MN encoding function E from BM to BN is called a group code if E of BM, that is E of B, where B belongs to BM, that is range of E. So for all B belonging to BM, if we consider the set of all images E of B, then that is range of E is a subgroup of BM. So if set of all images of elements B belonging to BM is a subgroup of Bn, then in that case we say that MN encoding function is a group code. Now already we have seen how to show that H is a subgroup of some group G. From the definition of subgroup, E of Bm is subset of Bn consisting of all code words is a subgroup of Bn if first the identity element in Bn is in E of Bm. So whatever is the identity element of Bn, it must be present in E of Bm. Secondly, if xy belongs to E of Bm, then x ring sum y belongs to E of Bm, that is binary operation or closure property. Third, if x is in E of Bm, then its inverse is also in E of Bm. Now, as in Bn, every element is inverse of itself. To prove that E is a group code, it is enough to show that E of Bm has identity element and x ring sum y belongs to E of Bm. Now we are not checking associative property because already it holds in Bn, so it holds in subgroup also. At the same time, for every element in Bn, its inverse is the element itself. So it is not necessary to check that inverse property. So whenever we have to show that some set E of Bm is a subgroup of Bn, we check only for the binary operation, that is closure property and existence of identity element. So whatever is the identity element of Bn, it must be present in E of Bn. Now show that 2,6 encoding function E from B2 to B6 defined by this way is a group code. Now according to definition, to show that E is a group code, we have to show that E of B2, that is range of E means set of all code words, is a subgroup of B6. So E of B2 is nothing but set of all elements E of 0, 0, E of 1, 0, E of 0, 1, E of 1, 1, which are images, that is called as code words. So we form the set C equal to E of B2, which contains code words first, second, third and fourth. Now we show that this is a subgroup of B6. Now according to remark, it is enough to show that identity element of B6 is present in C and C is closed under that ring sum, that is binary operation. Now the identity element of B6 is 0, 0, 0 6 times and it is present in C. So identity element exists in C, which is set of all code words. Now to check that binary operation or closure property, as it is a finite set, we prepare composition table. So we have written members of C as a heading row and heading column. Now the operation defined on C is that of same as B6, which is ring sum operation. So we add all these elements. So 0, 0, 0, 6 times, if you add any of that element, we get the same element. So first row is identical to heading row. Similarly, the column. Now addition we have to do like coordinate wise, like first, first, second, second, third, third, like that. In which 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, and 1 plus 1 is 0. So this is the table we got. Now observe the elements of this table. Now all elements are from C only. So we can say that the operation ring sum is closed in C, and hence closure property and existence of identity, both the properties are satisfied by C. Hence, the set of all code words is a subgroup of B6. So, by definition, we can say that E is a group code. Now, second example, show that 2,6 encoding function E from B2 to B6 defined in this way is not a group code. So not a group code means either closure property or identity element. One of the property fails here. Now to check that it is not a group code, first we form the set C, which is E of B2, range of E, which contains all the code words. Now first check for identity element. So identity of B6 is 006 times. See whether it is present in C or not. Yes, it is present in C. So the property of identity element is satisfied here. So we go to next step, that is binary operation. Now to check for binary operation, for xy in C we must get x ring sum y in C. But for at least one pair xy in C, if we are not getting x ring sum y in C, then in that case it is not closed under ring sum, means not a group code. So again we prepare the composition table. Now after preparing the composition table, it is observed that for x is equal to 1 1 1 1 4 times double zero, that means this element, and y is equal to double zero double one double zero. So x ring sum y is coming double one 4 times 0, and double one 4 times 0, that element is not present in C. So C is not closed under ring sum, and hence second property is not satisfied, and so by definition we can say that E is not a group code. Now next theorem, let E from Bm to Bn be a group code. The minimum distance of E is the minimum weight of a non-zero code word. Now we have seen the definition of minimum distance. So minimum distance of encoding function E is nothing but minimum distance between distinct pairs of code words. But in that case, we have to find distances between all distinct pairs of code words, which is sometimes very lengthy job. So if you know E is a group code, then directly we can apply this theorem to find its minimum distance. Because if E is a group code, then minimum distance of E is nothing but minimum weight of a non-zero code word. So just observe non-zero code words means other than 00. So for every non-zero code word, find the weight, and minimum weight of that non-zero code word is nothing but the minimum distance. Now, for E from B3 to B6, 36 encoding function, find the minimum distance. Now here first we check whether E is a group code or not. Now E is defined in this way. So to check for E as a group code, we first consider the set of all code words which are written on right side. So we have to check whether it is a subgroup of B6 or not. Now the identity of B6 is 0006 times, which is present here as a code word. So identity element exists. Now to check for xy in E of B3, x ring sum y is in E of B3, we prepare the composition table for all the code words. So as x ring sum y and y ring sum x is same, once you write row, you can immediately write the column diagonally. So from second onwards, we write in this way. Then from third, we write this row as well as this column. So this is the table that we are getting. Now observe all the elements. So for xy belonging to that E of B3, X ring sum Y is again in E of B3, and so ring sum is closed in E of B3. That means E is a group code. So to find the minimum distance of that encoding function, just we find the weight of each non-zero code word. Now this is the first E of 001. So as there are two ones, the weight is 2. So in this way, calculate the weight of each non-zero code word. Now minimum is 2, and hence minimum distance of that encoding function is 2. So without actual finding distances between distinct pairs of code words, here we have calculated the minimum distance, because actually it is not defined on B2. So when the encoding function is defined on B2, then we get only 6 pairs. But here the number of pairs, that number will be very large. So that job will be very lengthy. So instead of that, here we have shown that E is a group code, and using that theorem directly we calculated the minimum weight of non-zero code word, which is coming 2. So this is the minimum distance of encoding function E.